we're going to review the formulas that are key to doing well on the BC Calculus exam. We're going to start with some really key formulas that have to do with distance, and these are really review from Calc 1. And let's just take a look at this formula first. When you see the integral from a to b of v of t dt, you should realize that that is going to give you displacement. That's going to tell you how far you are from where you started. Now what happens if I do this? 1 over b minus a, the integral from a to b of v of t dt, that's an a. Hopefully you recognize that's going to give you average velocity. And I just want to do a unit analysis so we see what's going on here. B minus A, those are actually time values, because remember this whole thing is in terms of time, and B and A are time values, which means B minus A, let's say, would be measured in seconds in this particular case. We'd have the integral, and our velocity, let's say, was measured in meters per second. And then dt right here is measured in seconds. And when we do a unit analysis, we see the seconds cancel, and our answer is in meters per second, which is a measure of velocity. Then the other one we should know in this case is the integral from a to b of the absolute value of v of t. And when we do that, dt, we get total distance traveled. Now, oftentimes people confuse this with the other distance ones we're going to look at in a moment. But what we should realize about this is a velocity function, and this function can be at times positive and negative, but its velocity as where the motion is just about moving forwards or backwards. Those are the only directions we have, is forwards and backwards. Let's consider one other formula. What if I did this? 1 over b minus a, the integral from a to b of the absolute value of velocity dt. Now this is obviously an average again, but this wouldn't be average velocity because we no longer have signs. This is going to give us our average speed, because speed is the magnitude of velocity. All right, let's move on to formulas having to do with the length of a curve. And remember, we have three modes from those. We have function mode. And in function mode, this would be the integral from a to b of the square root of 1 plus dy dx squared dx. And that would give us the length along the curve. Now the mistake we don't want to make, we'll do this in red, this is bad, is to think that this gives you distance traveled. This does not give distance traveled. This is a function that has to do with the distance you've traveled in y with respect to your x position. Don't do this. If you want to figure out how far you've gone, you're going to use this formula up here. All right, the next mode was when we worked in parametric mode. So parametric mode, if we did this, we had the integral from a to b. It was the square root of dx dt squared plus dy dt squared. Now later on when we review our vectors, we know that this, the square root of this, is our velocity, or actually our speed, because this is always positive. And so when we take the integral of this, just like before, the integral of speed gives us the total distance traveled. Notice here this is going to be dt. Everything is in terms of t, including a and b. Our last mode was in polar mode, and in polar mode we would take the integral from a to b, square root of r squared plus dr d theta squared. And in this case, everything is in terms of theta. All right, let's move on to our next type of formula, which is formulas having to do with parametric functions. And for the AP, you definitely want to know that your slope of the function, which would be dy dx, can be found by taking the ratio of dy dt to dx dt. And well, we just talked about the length of a curve, so let's which is also sometimes known as your arc length. So the length along the arc, which would be the integral that we were just looking at, integral from a to b, square root of dx dt squared plus dy dt squared dt. So I've done that one twice, and it comes up with parametric equations as well. All right, let's move on to formulas that have to do with polar functions that we should know. And in this case, the first thing we should be able to do is to convert to parametric. So remember that to convert to parametric, we said x equal to r cosine theta and y equal to r sine theta. Remember, r is a function of theta. So r is a function of theta. Once again, we can find our slope, dy dx of the graph by taking the ratio of dy d theta over dx d theta. We should know that the area is 1/2 the integral from a to b of r squared d theta. And when we're looking at area, we should have a really good understanding that the area is not made up of a bunch of rectangles, but a bunch of sectors. So make sure you're clear on what we're looking at there. And then the arc length, which we just did, but I'll write it one more time. Arc length along a polar curve is the integral from a to b of the square root of r squared plus dr d theta squared d theta. All right, moving along here, we'll have formulas that have to do with logistic growth. So we should know this form, dp dt equals kp times 1 minus p over L. If it doesn't look like this, you want to factor out whatever's here so that it does look like it. So you have 1 minus and rewrite this as a fraction, because once we do this, we know a few things. So let's talk about k first. K is our growth rate if there's no limit in resources. If there's no limit on resources. L is our carrying capacity. So L equals carrying capacity. And then we should know that dp dt is maximized at L over 2, which is to say that it is growing the fastest when we're halfway to the carrying capacity. All right, so then we've got our formulas having to do with vectors. So we can have our position function, which for our purposes, we're going to call x of t, y of t, which tells us where our x and y coordinates are based on time. Our velocity is simply dx dt and dy dt. Our acceleration, which is our second derivative, and then we should also know how to find speed, which looks just like formulas we've had before. We've got dx dt squared plus dy dt squared. And then lastly, if we want to find the distance traveled, we've written this formula a few times, we simply take the integral of that speed function. So now we're going to have the integral from a to b of the square root of dx dt squared plus dy dt squared. And we will get the total distance traveled. All right, these are the formulas that you want to have down pat before the AP exam.